if you have any questions or comments or anything. Many? Oh, approximately 21 questions. They are all from the task one. Yeah, how many significant figures are there in your T number? Find velocity and acceleration for one-dimensional motion with the equation. Calculate final speed after absolutely inelastic collision. Solve the elastic collision problem. Find the center of mass. Solve the projectile problem. Find the acceleration of simple pulley. Find gravity, acceleration, orbital velocity, and escape velocity. Find acceleration of a mass at the inclined plane. Find the hangover of S blocks. Find angular velocity and linear acceleration. Calculate Schwarzschild radius. Calculate Doppler effect. Are clothes warmer or white clothes warmer? Of course, on average, on Earth, white clothes are warmer. So bodies in thermodynamically isolated system, and the final temperature, force between two charges, series and parallel circuits show that maximum loss occurs when R big is equal to R small in a circuit. Find the frequency and period of harmonic oscillator. I find V1 for the transformer. And what color is the sun? It's green. Sun is green. Yeah. So welcome, everybody. Welcome. Do you have any questions or comments about the midterm exam? Will you be able to answer these questions? I hope you will have access to the internet and to the books and to phones, computers, websites, YouTube, everything. Okay. If you have no questions about this, maybe it's better for us to look at the task. Or maybe before we look at the task, let's try to watch some videos. Yeah. So maybe we can start with block stacking problem if I can find the video. Block stacking problem. There we go. Okay. So let me try to share this with you. So block stacking problem. Okay, let me try to share. Stop sharing. Okay, where is my block stacking problem? Maybe this one. Okay. Can you see that?
How much of an overhang can you attain by dunking the bolts on the day? directly above the engine.
Yeah, do you understand?
Yes, sir.
I hope so. Yeah, so that's one of the problems we're solving. This is number well, I don't remember. Number 10, yeah? Hangover. For the S blocks. So each block is 1 meter. S is your student number, so approximately 22 million books or blocks. Yeah. And the hangover will be only about 16 books or blocks or meters or whatever you calculate the hangover in. Yeah. So let's see what else we can watch. I think simple pulley problem. Let's try simple pulley problem. Yeah, this one. So simple pulley problem is one of the questions that we are dealing with. Okay, let me try to share this one. Is it the one? Yeah, hope so. Okay, let's watch this.
And this time we're going to look at what we call the data, and actually all it is. He's placed over a what is it? Kilograms, let's say in here. Now the system. System and the total mass of the system. Fighting back in opposite directions. It's not a dentist problem. And there we say there. Complete the results. Which is the way that the object ends with. So A equals to 2 or 2.26. Well, if you were to explain so that paying attention on the I'm saying that we believe in what we do, don't we? All right. Kilograms. James. I guess. Equals and the whole
Questions, comments, do you understand? Do you understand the simple pulley problem? We solved it better than him, so he started to plug in the numbers, but we did it using letters. So we see that T1 is equal to T2. So we don't need to compare the numbers before we compare the letters. Yeah. So now let's watch inclined plane. Yeah, let's see. I think this one, right? Okay.
Point up or down. It's not the best way to solve this. So that's the direction we should care about. With this little perpendicular symbol here.
Okay. Do you understand the inclined plane? Yeah, he did it without friction, and we did it without friction and with friction. Yeah. So we did more than he did. Yeah. So now, if you don't have questions, let us try to watch about Doppler's effect. Okay, maybe this one. Just a moment, it will play. Okay, first let me make it. No. First let me share it, right? So Doppler's effect.
Navigation in studying the motion of stars. Theories of the universe. But what is it? A few feet away would see a wave come toward them. But would also with its arms and legs at the same frequency than the waves approaching an observer's head. It's an important concept. Buys-Ballot tested the hypothesis using sound wave, that a sound's pitch was higher than approached an observer, and this happens because the sound wave, as the waves recede, the observer will feel. As the effet Doppler fizzle. Naval architect and shipbuilder John. In astronomy, the Doppler effect is seen from us. It even helps us find.
Do you understand the Doppler's effect? Yeah, we solve a couple of problems for Doppler's effect, for sound and for light. Yeah. So the sound source is approaching the observer in our case, and the light source is moving away from the observer. Yeah. Okay, is there anything else that we can watch? Yeah, inclined plane. Yeah, okay. Good luck with this. Please make sure you can answer this. I hope you can have access to the internet and books and phones and computers and everything. But you must be prepared because it will be hard to answer all these questions, especially if you have no access to the internet, books, websites, phones, and everything else. Right? I hope that you will have access, but maybe you will not have access, so you must be well prepared. Yeah. So, any questions or comments, please? Okay. So, maybe then we can do the attendance, and then we get back to our topics. Yeah. So, attendance. Okay. Bayu Arif Setiawan, Muhammad Diyar Ramadan.
Yes, sir.
Thank you. Nabhan Muhammad Raihan,
Yes, sir.
Nurul Nabila, Khairul Ilham. Thank you. Okay, Muhammad and Hika Putra Pratama.
Yes, sir.
Okay. Ibnu Salam, Adam Apriyan, yeah, Ranga Raditya Putra Pratama, Muhammad Farid Ali Wahyuddin,
Yes, sir.
Muhammad Fauzan Bintang Afdisa, Carnelia Raisha Wulur, Virgi Febrian Hermawan,
Yes, sir.
Molisa Claudia Sapitri, Christian Jonathan Pascual, Siti Raihana.
Yes, sir.
Thank you. Aref Aprilianto, Grandi Damanegara,
Yes, sir.
Ali Sirajuddin,
Yes, sir.
okay. Brian Jonathan Hutapea, okay. Muhammad Haikal Bagus Putra, Muhammad Naufal, Zabrina Fitria Ramadhani Napitupulu.
Yes, sir.
Thank you. Okay. So, let me see what else we can do. I actually expected you to do more in your task 1 because very few of you answered questions, and those who answered, they answered only very few questions. So there are 100 questions approximately, excuse me, in task 1. and you answered maybe 5 or 4 if you answered them, yeah? So probably you are tired or you are busy, of course, I know that, but please try to look around and see physics around you and try to think how you can be safer, for example, with electricity, with cars, with motorbikes, with floods. Now, unfortunately, we've got the war in the world, very big war. So we must be super careful and must take care of ourselves and our family members. Yeah. I hope that you can go to other countries to work and study. And for that, you are expected to do well in your studies, to have high scores. So please try to do your best, you know. I know it's very, very hard to study in Indonesia, especially in Jakarta. It's hard to breathe. So many people, hard to travel, heavy traffic, you know. So it's hard, but let's try our best, yeah? Okay? So maybe we can go through the task, yeah, and see what we can do. If you have no questions. Okay, so this one must be S, right? Anywhere else? I hope only here. Okay, so let's try to do task 1. Yeah. Oh. Okay. Present. Okay. Okay, no worries. Yeah, sorry for that. Yeah. So please try to watch YouTube videos about our topics like inclined plane, Doppler's effect, simple pulley problem, hangover problem, and all the other things, because the videos are really, really good. They explain things so well. Usually the best professors produce those videos, and usually they're very, very, very good. Yeah. Okay, so let's try task 1. Okay, so once again, what do you want from this physics course? About your project, and then units of physics, base units, 7 base units, expressing 1 units through the other units, then accurate and precise. Please answer only for your student number. Please answer only one of these 4 questions, depending on your M4. M4 is the student number mod 4, okay? So significant figures using either Atlantic rule or Pacific rule, yeah? Classical mechanics. When you answer where classical mechanics be used, please say something like classical mechanics fails for big speeds, for small distances, and small masses. Yeah, something like that. Don't tell me that classical mechanics is used in engineering, in science. Please don't say that, because that's irrelevant. Yeah. So I would like you to give your own definitions of these things like distance, displacement, mass, gravitational mass, speed, etc., etc., etc. In your own words, please. You can read, you can listen, you can watch, but when you write, please don't copy. If you don't know, then just don't write, yeah? So we define material point, kinematics, and you can calculate velocity by taking the derivative of x. And the derivative is going to be 2t big times t small plus L, right? That's velocity in meters per second, and acceleration is going to be equal to 2 times t big, yeah, in meters per second squared. So then we do collisions, absolutely inelastic collision, then absolutely elastic collision. Write your student number And that's about it, right? Yeah. So already one significant figure here. So just your student number and that's it, yeah? Then absolutely elastic collision, it's a bit more difficult, but still manageable. You can solve it. But in this case, you don't even need to calculate, even though you need to tell me how many significant figures depending on your student number, yeah? Okay. Then center of mass. So once again, just write your student number and the number of significant figures, maximum 4, but how many? Maybe 3, maybe 4 significant figures, yeah? So I cannot pull myself out of mud because internal force cannot change the location of the center of mass. Because some of you write, oh, you can pull yourself in this way, in that way, depending on the mud, depending on this, depending on that. No. So I assume that there is no friction in the mud, so I cannot get out. Someone else should help me. I cannot pull myself out of mud, yeah? So define mass again. So the weight is mass times g, but make sure only one significant figure, yeah? So not 750 newtons in this case, but approximately 800 newtons, approximately, so around 750 rounded up to 800 newtons, yeah? Excuse me, many problems about projectile, yeah? I tried to correct the mistakes, but there are still some errors, yeah? For example, let's see here, T1 and T2 is correct, but this equation, xt squared plus x minus 2yt minus x plus y is equal to 0, this one is incorrect. It's incorrect, yeah? And I think derivative is also incorrect. Yeah, so this one is incorrect. So I will try to fix it. If not, you please try to fix them, yeah? So the last, this one is correct. As you can see, so simple and beautiful. So I ask you to check and to check and check and check many things about projectile, yeah? Prove things about projectile. Now, truck is more efficient than trolley in our case because truck rotates the wheels, whereas trolley is pushed. So for truck, friction helps motion. For trolley, friction opposes motion. And probably the most important question about colliding eggs. So the moving egg is more likely to crack than a stationary egg, yeah? And big foot is worse than small foot for soccer players statistically. Some of you try to argue that it depends on skills. Of course, it depends on skills, but we assume the skills are the same. And I did statistical analysis of the top players. Maybe I can show it to you, maybe later sometimes. Excuse me. In the future, you see that the average height of the professional soccer players is approximately 6 feet, but the most successful soccer players are like several centimeters shorter on average, yeah? So there is a significant correlation, and it is statistically significant, so probably it's better to have smaller foot, excuse me, to be more successful soccer player, to kick the soccer ball more accurately and more precisely. Yeah, so this is the air purifier volume question. I hope you can answer that just by dividing one by the other. So no units, just the number. In this case, now pulley problem, we have watched the video. As you can see, I solve it for much more general case, yeah? and you can solve it for any case. Yeah. So this is about friction, kinetic friction, static friction. So you calculate the friction force. Yeah, make sure you give the correct number of significant figures in this case, either 1 or 2, depending on your student number. Yeah. So mv is equal to ft. This is just the simplified Newton's law. And we solve a couple of problems using this equation. The dust particle for the air purifier, and also the biker moving from rest with the friction. Yeah. Some questions about rotational motion. As you can see, the acceleration for rotation is equal to v squared over r, where v is the linear velocity, r is the radius, or it is also equal to r times omega squared. Here, r is the radius of rotation, and omega is angular velocity. Yeah. So we deal with rotation quite a lot. Now, if you break the rope while rotating the mass, then the mass will continue in tangential direction. So you removed all the forces, you removed all the torques. So moment of force is not applied. Momentum is constant. So please don't discuss how the rope was broken, what kind of forces were associated with that, what kind of torques and stuff like that. No, there were no forces, no torques, just no forces from now. So you snap the rope and that's it. So momentum will be conserved if there are no forces, no torques. Yeah. Okay. So you compare translation and rotation in your own words again. Energy is ability to do work, and power is work divided by time. So work in 1 second, or derivative of work with respect to time. Yeah, conservation laws are the result of symmetry of our time and space. So if the force is conservative, then derivative of the energy is equal to the force, just like for gravity force. Derivative of mgh with respect to h is equal to mg, which is the gravity force, right? And here is the gravity law of Newton, g big times mass 1 times mass 2 divided by the radius squared. Radius is the distance between the masses, between the centers of mass, of each mass, right? So I ask you to calculate the difference in weight on the equator and on the pole, and the difference in distance in the radius is 21 kilometers. Yeah. So you have the radius of the Earth and then mass of the Earth, and you calculate the first force and then the second force, and you compare them. Yeah. Okay, so we calculate orbital velocity, escape velocity, and gravity acceleration using the radius of the planet, mass of the planet, and the gravity acceleration for the planet. In this case, Earth. So everything is known for Earth, so we can calculate escape velocity, orbital velocity, and gravity acceleration being approximately 10 meters per second squared, orbital velocity approximately n kilometers per second, and escape velocity approximately 11 kilometers per second. So work energy theorem solves almost every problem in classical physics. So change in kinetic energy of mechanical system is equal to work of all external forces and all internal forces. So using this theorem, we can solve almost all problems, including problems for solid mechanics, where you will need to use moment of force or torque, which is distance and force, the cross product of distance and force. Yeah. Free body diagram means that we remove all the bodies and substitute the influence with the with the forces that we draw, and that's the diagram. So inclined plane, we have seen that, that's for no friction. And then for friction, and there is a code for friction, so you can solve it for your student number. Acceleration is meters. Okay, how many significant figures? Now, let's see, how many significant figures? One significant figure, right? Let me write it down. One significant figure. Yeah. Okay, the block stacking problem, we watched the video about it, and the code calculates for your student number. Just write your student number everywhere where appropriate, right? And correct number of significant figures. So we calculate acceleration, torque, and force using the equations, giving the correct number of significant figures. So once again, rotational motion. Yeah. Rotational motion due to rotation of the Earth. Yeah. So potential energy is mgh in this case, and kinetic energy mv squared over 2. So both measured in joules. One is to one significant figure, and the other one is maximum 2 significant figures. So either 1 or 2 significant figures. Yeah. So static equilibrium for the simple Pauli problem is when both masses are equal to each other. Yeah. And black hole can be calculated if we use Newton's gravity law, and we squeeze the object of mass m to such size that even the light cannot escape. The gravity pull is so strong. So the escape velocity becomes the speed of light. So that's how we calculate the radius of the black hole, or Schwarzschild radius. Yeah, that's the proof. Okay. Also, we introduce the special relativity correction to the Newton's equations. Yeah. So calculate this square root, please. If it is close to 1, then there is no correction. But if it is significantly different from 1, then there is a correction. Yeah. There is chaos in classical mechanics through double pendulum, and inertial force is a fictitious force because of reference frame not being inertial, and it may be the result of the attraction of distant stars. Whatever you think, just write it down. Whatever you think is more correct. Maybe you have your own opinion, right? So now solids is motion of the center of mass of the solid and rotation around the center of mass. So solids have moments of inertia, and that's how we calculate torque using matrix of the tensor of inertia and vector of acceleration, angular acceleration. Yeah, so these are the notations through the sum. And then we calculate torque using, and then we calculate acceleration using the Cramer's rule to solve simultaneous equation for acceleration. Yeah. So that's how we calculate the torque. And then to calculate acceleration, we need to solve simultaneous equations, and that's how we solve them. That's how we get simultaneous equations solutions, and that's how we calculate the acceleration. Yeah. Okay. Oscillation. We calculate the period of the spring and mass attached to the spring, period of mass. So that kind of oscillator, a harmonic oscillator, and also another harmonic oscillator, pendulum. We also calculate the period. Only one significant figure for pendulum. So question about harmonic oscillator. You're given the solution, you just plug the numbers and you give the answer. Now, this is a harmonic oscillation differential equation. please try to use wolframalpha.com to solve it and plug T, your T from your student number. T is your student number mod 100. Yeah. The resonant frequency is basically the square root in this case of L over T. Yeah. And the vibration with damping, again, I ask you to use wolframalpha.com to calculate the solution of this differential equation. Yeah. So the wave is the spread of oscillation in space, and we solve the string oscillatory equation, the most simple differential equation to describe string oscillation, for example, guitar string. And this is the solution, okay? The interference is basically the sum of the waves, and sometimes they add up, making the constructive interference. Sometimes they are subtracted, so causing destructive interference. Yeah. So this is the solution for interference. Okay, then sound Doppler's effect. We've been watching the video about that. In this case, the wavelength changed from 17 meters to 16 meters. So the source of the sound approaches the observer. And when you calculate the speed, it will end up being approximately 20 meters per second. So that's being just a car or something, or motorbike or something like that. So elastic force is a conservative force, and this is the most general equation for elasticity. Plasticity is irreversible deformation. Fracture can be calculated using the simple pulley problem. If T newtons is the breaking point, then the mass which breaks the rope is going to be equal to T newtons divided by gravity acceleration on Earth, right? Because mg is equal to T, right? The mass which breaks the rope is equal to T divided by the gravity acceleration g, yeah? So there is electromagnetic nature of friction, elasticity, plasticity, fracture. Okay. So now fluid, the static pressure of the fluid, and then the calculation, then the buoyant force, also calculation of the buoyant force. For your student number, Bernoulli's principle and Magnus effect, in combination, they cause the tennis ball or soccer ball rotate while they fly. If they have spin, then they usually rotate. I mean, they turn their direction. Yeah. So in thermodynamics, we solve several problems. For example, we realize that white clothes is usually warmer on average on Earth, because human body's temperature is much higher than the average temperature on Earth. Yeah. If the body is heated, then they expand. And I try to correct my mistakes. I try to give you the correct answer to the distance change and volume change. So change in volume is, okay, 1 or 2 significant figures, yeah? Okay. Change in distance, 1 significant figure, right? So 1 significant figure. For length, for the length change. And either 1 or 2 significant figures for the volume change. For volume change. Depending on your student number, okay? Okay, so the heat flows from hot to cold usually, and if the bodies are in thermodynamically isolated system, eventually the temperature will be the same and it's weighted average. So let me give you a student number, for example, 2, 1, 2, 3, 4, 5, 6. For example, this is your student number. So just write your correct student number, and then you calculate for your student number, and you find out the final temperature, yeah? So pressure P is directly proportional to velocity v squared for the ideal gas, and energy of the particles is 1.5 K times temperature. K is the Boltzmann's constant. It's on your screen. This is the equation for ideal gas. Okay. So we find the pressure. I give you the code. The interaction of particles does not exist for the ideal gas. In other words, the collisions are absolutely elastic. Yeah, but for real gas, the particles have some size and there is interaction between particles, and we calculate the pressure again, this time for ideal gas, okay? So you don't need to prove the heat transfer equation solution. Just be aware of that, yeah? I don't want you to do the differentiation and stuff like that. Okay, any questions or comments before we do electromagnetism? Oh, sorry. Okay, so let's try to do electromagnetism. So firstly, we start with the definition of electric charge, electric field, electric current, okay? And then electrostatics, we use Coulomb's law, which is similar to Newton's law of gravity. Let me see, do I write Coulomb's law somewhere here? No? Maybe not here. But in the code, there is Coulomb's law, right? So Coulomb's constant times first charge times the second charge divided by the distance squared, yeah? So Coulomb force can attract, just like gravity force, but Coulomb force can also repel. So the gravity force cannot do that. At least in our part of the universe, we have never discovered that, yeah? So the uniform electric field, and we solve it for the voltage, right? Then a field force is intensity of electric field times charge. Okay. Now electrodynamics includes electrical circuits. So the electronic elements, Ohm's law for the section of the circuit, we calculate voltage. Yeah. Then resistivity is key thing because we deal with semiconductors very often. So for semiconductors, resistivity is kind of in the middle between isolator and conductor. Yeah. So we calculate resistance given the resistivity, given the length of the wire and cross-sectional area of the wire. Okay. So we calculate the compound resistance in series and in parallel. So in series, you just add the resistances, but in parallel, you go compound resistance. 1 over compound resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And then you calculate compound resistance from this equation, yeah? And we know now, hopefully, that maximum losses in a circuit occur when active resistance is equal to the internal resistance of the source of electromotive force. And we prove it by taking the derivative of the losses and equating derivative to 0. And then we prove that that's maximum. Yeah. So we calculate the frequency and the period of harmonic oscillator. In this case, it's electromagnetic oscillator. It's LC circuit, harmonic oscillator. Yeah. So I encourage you to look through this chapter 21a, because it solves many problems, not only the RC circuit problem, but also transformer problem and energy transfer problem. Yeah, I think I showed you the gates, not gate, AND gate, OR gate, using transistors and circuit. Yeah, please explain only for your student number depending on your M3. M3 is your student number mod 3. Yeah. Now, the transformer has the primary coil and secondary coil, and there is a formula linking those coils, so you can calculate voltage in the primary coil. So this is your student number. Yeah. So either one or two significant figures. Now, this is super important that it's much better to transmit high voltage, because the losses will be much smaller than if you transmit low voltage, because the current for low voltage will be bigger, right? We know it from Ohm's law. And then the losses will be bigger for small voltage, and the losses will be smaller for big voltage. Yeah. So this is the electric motor. This is the formula for the torque: number of loops times the current times magnetic field times the area. That is going to be the maximum torque, and the minimum torque is obviously going to be 0 if one of those things is if one or more of those things equal 0. Yeah. So the lamp of T watts power emits electromagnetic radiation in all directions. It's assuming a lamp to be a point source, calculate the intensity at 1 meter, at 2 meters, and the intensity is power divided by the surface area, and we know the surface area of the sphere is 4 pi r squared, where pi is approximately 3.14 and r is the radius of the sphere. Yeah, so that's how we calculate the answer. And then similar problem about the amplitude. So amplitude squared is directly proportional to the intensity. We calculate the amplitude, and the units are very hard to determine, but the simplified version is just for electric component of electromagnetic wave, volts per meter for electric field. Yeah. But I mean, to do it properly, we should multiply electric field by electric permeability of the space or the environment, and then magnetic field by magnetic permeability. Then they become in the same units. Then we should add the squares of them, and then it will be directly proportional to the amplitude squared. Yeah. So it's a very complex question about the units, but I'm giving you the simple answer, probably some simplified answer, right? So this is about refraction. The speed changes, the wavelength changes, the frequency stays the same during the refraction. That's how we find the wavelength in the media. Yeah. So this is astronomer thing, is about Doppler's effect, this time for the stars, for the light. In this case, the source of the wave is moving away from the observer, right? In the case of the sound, it moved towards the observer, but the formulas are still the same. So please calculate the speed and give the direction, which is obviously away from the observer. Okay, double slit experiment allows you to calculate x, that's the distance between maxima on the screen. A is the distance between the slits. D is the distance between the slits and the screen. Lambda is the wavelength. So you calculate x if you are given everything else. And similarly, diffraction grating, this time you calculate the number of maximum, which is just the number. Can be 0, 1, 2, 3, 4, 5, 6, 7, etc., or -1, -2, -3, etc. So you just calculate it by rounding it so that it's just a natural number. It's dimensionless and no need for significant figures, obviously, right? So, so solving simplified Maxwell's equation, it's almost the same as the equation for oscillating guitar string. Yeah, mathematically they are the same, just the speed of light instead of the speed of a mechanical wave. Those are the differences, but only insignificant. Now, the sun is green, and you can calculate the color of any star if you are given the temperature of the star. For sun, it shows that the sun is green, and you can see it in the publications on the internet. Many people are surprised, saying that sun is either red or yellow or orange or white, but no. Firstly, white is not a color, it's a mixture of colors. Secondly, the sun is green, and you can calculate that, yeah? So the plane mirror has this property that angle of incidence is equal to the angle of reflection. Using this property, we can calculate the size of the mirror and the location of the mirror so that the man can see his entire, his whole body, so minimum size of the mirror. For convex mirror, the magnification is a positive number, but less than 1. It's less than 1, yeah? Please make sure you do it correctly, okay? Now, a spy satellite can recognize T centimeters objects, yeah? So T is used to the number mod 100, so you calculate the size of the lens needed, yeah? So usually it's, when you calculate, it's usually between 2 meters and maybe 10 meters, something like that. So if you get, let's say, 1,000 meters, that's probably wrong. Or if you give like 1 centimeter, probably also wrong, yeah? Okay, any questions, any comments, please? Anything? You are so quiet, you know? I've been speaking for almost 2 hours, right? So for 1.5 hours, right? And you've been quiet. Why? Please say something. Please ask questions. Give comments, please. Yeah. So please try to be creative and try to enjoy physics. And try to get high scores in your exam. Yeah. So I will try to give you the exam paper if I can, if I'm allowed, so that you can prepare better. And yeah, just try your best and enjoy. Yeah. So questions, comments, anything? Okay. I'm thinking of maybe watching some videos again. Let's say, how about we watch? Let me see what else I can find in the exam. Oh yeah, I think we haven't watched about the black hole radius. Did we? I think we didn't. Let's try. Okay. Okay. Let me stop sharing this. Let me go here. I think we haven't watched about the black hole's radius. Let's try. Sorry. Okay. So let me try to share that black hole. There we go.
Very, very heavy. A lot of mass crammed into a depends. Black hole are either from very much population of moving points yourself. Shield radius of a black hole and the equation for the mass of a spherical object. The Schwarzschild radius is the distance from the center horizon, and how big it is. So the equation can also be written as 1.49. Total radius of the Earth is about 1 centimeter. That is about 0.1 yocto. The stars already dense north past their short tipping point. But suppose you don't have access to supernova strength. Instead, make a black hole by adding more mass to your object. The mass of a spherical object is equal to the density of the material in question times the volume it takes up. Or partial radius starts off really far. Anything until the entire object by the Schwarzschild radius. But it's mathematically guaranteed. So to be honest, rock as for neutrons,
Okay. So I hope you I hope you understand more about the black hole now. Yeah. So we used classical physics to describe the black hole's radius. Yeah. So is there anything else we can discuss? I'm thinking what other topics we can discuss. Okay. Please ask questions or give comments while I'm trying to find what we can watch. Projectile, well, we've been dealing with projectile quite a lot. Doppler's effect done. Yeah, I don't really see what else we can do in terms of the videos, but you please do watch YouTube videos about physics if possible, and about many other things. YouTube is really great, and you know, sometimes you can find really good videos there, and like the best professors, like very good professors, they explain really well. Yeah. So hopefully they will not block YouTube in Indonesia, but they may block. So please try to watch it when you have a chance to watch YouTube while it is still not blocked in Indonesia. Yeah. So I try to watch YouTube quite a lot, and I try to learn from YouTube. I hope you do too. Yeah. So please, questions, comments. I really hope that you can do the exam well, because it will help you with your scholarship, your fellowship, especially if you have good score and good knowledge. And please learn something new, something useful from this class of physics. Yeah. Okay. So why don't we just watch some of the physics course, for example, from Yale University, this guy. Yeah. So I'm trying to find maybe this one, vectors, multiple dimensions. No, vectors, multiple dimensions.
dialogue.
Yeah, so let me try to share this. Maybe we can watch, but it's a long one, right? I don't think we can watch this one. It's for an hour. Anyway, I would like you to watch Yale University physics course. I mean, for example, law of Newton, work energy theorem, law of conservation. Yeah. So in just a few minutes, you will know a lot. Maybe we can find something shorter. Let me see. This crash course in physics, but still it's quite big, right? 47 lessons. Okay. What is physics? Yeah, Khan Academy is quite good. So please try to watch their videos. They're really good. Yeah. Anyway, what else can we do? We don't really have much time to go through the slides, through the lectures. Maybe you can ask me some specific questions. What do you think? Okay, so if you don't ask questions, then maybe we can try to go through the lectures, right? Okay, so let's try. Maybe I can show you the soccer players analysis, the size of the player versus the success. As you can see, Maradona, Pelé, Messi, number 3, old Ronaldo, and Cristiano Ronaldo, number 15, old Ronaldo, number 7. So this is from this website, yeah. And as you can see, the smaller the player, usually the more successful he is. Well, probably because it's easier to kick the soccer ball more accurately and more precisely. Yeah, I have done some statistical analysis, and it seems to be statistically significant. Yeah. Okay, so this is to illustrate what we have been discussing. And let me try to share the where is it? How can I find? Maybe no. Oh, show all windows. Okay. Okay. Okay, let's try this one. Number 1, yeah. So number 1, introduction to physics. Yeah, so that's what we start with. So the questions are basically the same as we discussed in the task, but maybe in more details, right? Basically, they are the same. Yeah. So we calculate the final speed of absolutely inelastic collision. We find the velocity and acceleration if you are given the equation of the motion. Yeah. So then I ask you to do your project, and we solve the projectile problem. Yeah. So that was the short one. Let us see the second one, which may be bigger. Yeah. Yeah, the second one. Yeah, here we discuss classical mechanics, limits of classical mechanics, right? Classical mechanics fails for big speeds, small distances, and small masses. Yeah. So basically, it's the same as the task. Well, what I did, I just put all this stuff into the task. We have gone through this when we have been going through the task. Yeah. So that's why, please, maybe it's better for you to ask questions and to give comments, because we have done this already. Maybe it's not very productive to go through this again and again and again. Yeah. So that's why it might be better if you can ask specific questions if you don't understand something. Yeah. Okay. So what I suggest, if you don't have questions, maybe we can finish for today. So today we considered classical mechanics, thermodynamics, and electromagnetism. You know, what I noticed is that it's hard for you to do the task. I don't know why. Maybe because you're busy, maybe because you are tired. Yeah. But let's try to do what we can. Yeah. Let's try to finish this class and have high score, and you know, move to other classes and focus on other classes. So it's quite important that you will get you know, good score in every class, including physics class. Yeah. So okay. So would that be okay if we finish for today? What do you think? Hello? Can we finish for today? Do you want to go until 9 p.m. or maybe it's enough for today? What do you think?
I think it's enough, sir.
Yeah, okay. So I really would like you to you know, participate more actively so that I could see, you know, how I can help you better. Because if you are quiet, if you don't submit the tasks, then it's really hard for me to help you. Yeah. So try to watch videos, try to see physics around you, like safety things, like safety with electricity, with cars, motorbikes, floods, everything. You know, pollution, you know, many things which are around us, they are physics. Yeah. And if you are dealing with drones, if you're a drone operator, you really need to use physics quite a lot. Yeah. And it's better for you to know how it works, because if there is a mistake, it may be easier for you to fix the mistake. In other words, I would like you to be more involved and to try to see physics around you, try to live physics, try to understand physics, try to, study physics, okay? So I hope you can do that. And I hope you can enjoy physics. It's also very important that you enjoy what you do. There is so much fun in physics. It's so beautiful. It's so useful. Yeah. Okay. So if you don't have questions and comments, then thank you so much. Thank you so much for your patience, for your time, for your effort. Terima kasih banyak, and goodbye. See you later.
Thank you, sir. Goodbye and good
Thank you.
night.
Bye.
Good night.